Hello to all you wonderful geometry students out there. My name is Mr. Delora, and this is our geometry course for the year. So we are going to jump into some content and talking about geometry. But before we do that, it's important to review some of the algebraic concepts that we have learned in years past. So today we're going to start off with a little bit of basic algebra review. Something that might be familiar to you guys is the acronym PEMDAS, or Please Excuse My Dear Aunt Sally. And this refers to how we solve or simplify using our order of operations. So we often start off by evaluating anything that's found in parentheses first. Now, parentheses are just one of many grouping symbols. So actually, we might want to refer to this acronym as GEMDAS. Grouping symbols also include the square root symbol, parentheses, but then there's also the absolute value symbol. So we're going to evaluate anything under a square root or inside an absolute value or a fraction bar, such as the operation a plus b divided by c. So we would first handle what's in the numerator before doing the division of the sum of a plus b over c. So those are grouping symbols, and we're always going to want to simplify those first. Next comes exponents. Exponents are also known as powers or degrees, and those are going to be handled after we evaluate anything that's found in a parenthesis or a grouping symbol. Then comes multiplication and division, and we're always going to move from the left to right. Just like we're reading across the page, we are going to solve multiplication and division problems in order, going left to right in our algebraic sentences. And then comes addition and subtraction, and likewise we're always going to simplify those in an order of left to right. Algebraic expressions are simply combinations of numbers and variables. Now, some examples of expressions would be simply like 2x. We have a number 2 that's called the coefficient in front of the variable x, and this rarely represents that we have two x's being added together. Another expression might be negative 3y cubed. Here we have the variable y, and this superscript 3 really represents that we're multiplying 3 by itself 3 times. This negative 3 in front of the y cubed is our coefficient on that. So these are expressions. Now, expressions might also have more than one variable and actually no coefficient. So you might have something like this, a, b, c, all divided by d. This also is an algebraic expression. Like terms are terms with the same variable to the same degree. Or another way of saying that is have the same exponent. So up here in our examples of expressions, we actually have no like terms because none of these have the same variable to the same degree. Now, I might throw in another expression like 4y cubed. Now we have negative 3y cubed and 4y cubed. They have the same variable to the same degree or the same exponent, and they are considered like terms. Let's take a look at a few examples of like terms and see if we can combine them. Example 1 just asks us to evaluate, are these like terms? If so, combine them. Combining simply means adding or subtracting them. All right, so we have a 4x and a 4y. They don't have the same variable, although they do have the same exponent. The exponent on both x and y are 1. They do have the same coefficient, 4, but that does not allow us to combine them. So we say that these are not like terms. All right, our next couple, we have 2t squared and a negative 3t squared. Same variable, same exponent, we can combine them. So because I have 2t squareds and then I have a negative 3t squared, I have a total of negative 1t squared. Now notice we're just combining their coefficients or the numbers that are in front of the variables. We're actually not combining the variables in their exponents. 9ab squared and 2ab squared over 5. Now another way to think about 2ab squared over 5 is to write it as 2/5 ab squared. And this one here is 9ab squared, and these have the same variables, a to the first exponent and b to the second exponent, and therefore they can be combined. Now 2/5, the decimal equivalent of 2/5 is 0.4, so this is 0.4 ab squared. And if I add 9ab squared to that, I'll have a total of 9.4 ab squared. All right, next we're going to do some examples of using our order of operations, PEMDAS or GEMDAS. and simplify these expressions. So here as I look across, I see I have a 2 plus 7 times 3 plus 5. Now order operations would tell me that I need to first do my multiplication and division before I do my addition and subtraction. So I'm going to rewrite this as 2 plus 21 plus 5. Now when I add, I can add left to right. That gives me 23 and 5, which is 28. All right, our next example, we have 4 times 6 divided by 8 times 1/3. Now these are all multiplication and division. Therefore, I'm going to do them in order left to right. 4 times 6 gives me 24. Divide that by 8 times by 1/3. I now have 4 divided by 8, which is 3. 3 times 1/3 is going to give me 1. Our final example of that one, we're going to take the square root of 13 minus 4 and cube it, raise it to the third power that is, minus 18 divided by 3. So I see that I have a set of parentheses. That parentheses needs to be done first, which has a square root, which means I need to first do my subtraction. So I'm going to take the square root of 9 before I raise it to the third power, and then I'm going to subtract my 18 divided by 3. So the square root of 9 now becomes our next process we need to do, which is 3. And then I'm going to raise that to the third power. And then I'm going to subtract my 18 divided by 3. 3 cubed is 27. 27 minus 18 divided by 3. Now I'm going to simplify it to 6. And that's going to give me a remaining amount of 21. All right, simplifying my expressions. Now when I simplify an expression, I'm going to combine my like terms. So I see here I have an x plus 3. Those are not like terms, but x plus x is. And another x. That gives me a total of 3 x's. And I have a total of 1, 2, 3 positive 3's, which would mean I really have a total of 9. So that gives me a 3x plus 9. This is a simplified expression for what I had here in letter A. Now that's different when I multiply them. Here I'm going to multiply 2t times 2t. When I do that, this is all multiplication, so it becomes 2 times t times 2 times t. I'm going to rearrange a few things here so that I multiply my numbers, and then I'm going to multiply my variables. A t times a t, now be careful, is not 2t. It is actually t squared. 2 times 2 is 2 squared, which is really 4. So my final simplified expression is 4t squared. Next up, I have addition again. I have a 4xy plus a 4x plus a 4y. Now, as I look across these, all three of them have the same number, but none of them have the same variable. And therefore, there are no like terms, and I cannot combine them anymore. So this is as far as I can simplify this expression. All right, finally, this one's for you guys to try on your own. I have 4 integers, 2, 3, 4, and 5. I want you to use them each once and create a mathematical sentence with these operations, plus, minus, times, divide, such that the total equals 10. I'm going to give you an example. Let's say we have 2 plus 3 times 4 minus 5. Now, as I do these order of operations, I know that I need to multiply my 3 times my 4 first. So this becomes 2 plus 12 minus 5. However, this is not going to be equal to 10. My challenge for you is to come up with some sort of mathematical expression. The numbers don't need to go in order. I just so happen to put them in order. But they can go in any order with operations between them, and the target they have to hit is 10. Good luck.